डियर स्टूडेंट, जो मैंने पिछला वीडियो लेक्चर था जिसमें मैंने डिफरेंट मोड्स ऑफ हीट ट्रांसफ़र पढ़े थे, तो हमारा यूनिट 1 में अभी कंडक्शन चल रहा है। तो कंडक्शन का जो अगला टॉपिक है, अभी मैंने एक सिंगल वॉल के बारे में आपसे बात किया था कि अगर इन केस ऑफ सिंगल वॉल इफ़ देयर इज़ ए टेम्परेचर डिफरेंस देन वी हैव ड्रिवन द इक्वेशन ऑफ heat transfer equation Q by using Fourier law of heat conduction. Now we are going to study steady state conduction through a composite wall. What is composite wall? A composite wall consists of many heterogeneous layer. When we fix them like plywood, if there is no gap between the layers, then how heat transfer is conducting from first wall to the last wall. So we are going to drive a relation for this. This is also called the composite wall derivation. So just I am going to make a diagram. So first of all, writing the equation, steady state our today's topic is steady state heat conduction through composite wall. So as I told you earlier, when we are going through any derivation, we proceed any derivation through 3 simple steps. The first step is the relevant diagram, then relevant assumptions, because any derivation cannot complete when we have certain assumptions. So we will take assumption as things proceeds, and lastly we equate the certain things and then derivation completes. So first of all, diagram is like this. This is layer 1, this is layer wall 2, and this is wall 3. So just I am going to assign the values. W1 wall 1, W2 is wall 2, and W3 is wall 3. Take thickness as delta 1. Del 1 is thickness of wall 1, del 2 is thickness of wall 2, and del 3 is thickness of wall 3. Okay students, del 3 is the thickness of wall 3. Let me assume that temperature of the first wall is T1, then it is T2, then T2 to T3, then T4 is this. So we have T1, T2, T3 and T4. Here we assume that the temperature of the wall, surface temperature of the wall 1 T1 is greater than the last surface temperature is T4. Then T1 is greater than T4. We are assuming here, this is the assumption. Okay, and now other things are, suppose the area of cross section of the wall 1 is A, and since these 3 walls are connected like their cross section area are same, so they are in series connection. So cross section area of wall 2 is also A, and the cross section area of wall 3 is also A. So all 3 walls have the same cross sectional area. Suppose thermal conductivity of wall is one is K1, another wall 2 is K2, and thermal conductivity of wall 3 is K3. So as we हमने पहले भी पढ़ा हुआ है, as we studied earlier, that heat transfer is always in the direction of decreasing temperature. So here T1 is more and T4 is less, so heat transfer is from left to right. So I can make the diagram of heat flow like this. Suppose Q is the heat transfer rate, so it also the same heat flow through the wall 1, again it's through the wall 2, and again 3, the same heat is going in the wall 3 and the outside wall 3 Q is coming out. So Q is the heat transfer rate. Okay, so now we can construct the thermal circuit of this diagram. The thermal circuit consists of, we can assume whenever heat transfer takes place, I have told you earlier that whenever heat transfer takes place, then there is a resistance to the heat flow. This resistance is called the thermal resistance. We have three walls, so we have three thermal resistance, RT1, RT2 and RT3. So I can draw the thermal circuit like this. This is the sign of resistance. Okay, so this is lead, this is RT1 thermal resistance offered by the wall 1, and RT2 is the thermal resistance offered by the wall 2, and this is RT3 thermal resistance offered by the wall 3. Now temperature of this temperature is T1, again this temperature is T2, again this temperature is T3, and this temperature is T4. As you see that heat enters from left side Q, it's the same heat transfer passes through the wall 1, so it is Q, again it's also passes through here, it is again Q, and this is again Q, or it's coming out from the wall 4, again the same Q. As you know that when the heat transfer rate is same, then all three walls are in a series contact. So we can add the thermal resistance, total thermal resistance as RT1, RT2 and RT3, and likewise we can drive the relation. So we are going to drive this kind of relation, Q is equal to delta T upon sigma RT. This is the relation we are going to drive in this topic. Okay, so how we can draw it? So next is the assumption. There are some assumptions also, because no derivation is valid when without any assumption. So here are some assumptions. What is the assumption we can take? We can take first assumption is thermal conductivity K1, first assumption is K1, then K2, K3 is constant, their value not change, constant. Number 2, cross-sectional area A1 is equal to A2 is equal to A3 is equal to A. Since their cross-sectional areas are same, so they are in series connection. And cross-sectional areas are different, they are a parallel connection. So here all the three walls have the same cross-sectional area, so they are in series connection. Next, what we are going to let del 1 del 1 comma del 2 comma del 3 are thickness of wall W1, W2, W3 as shown in figure, this figure. Okay, then fourth is the temperature T1 comma T2 comma T3 comma T3, and this is T4, where T1 and T4 are surface temperature, and T1 and T3 are the interface temperature. Interface T2 and T3 are interface temperature between wall 1 and 2, between W1 and W2, and W2 and W3. Okay, Q is the heat transfer rate. Let Q is the heat transfer rate, and sixth is the one-dimensional heat flow. One-dimensional heat flow along x-axis from left to right. Okay, so now we can now we are going to proceed like this by using Fourier law. By using Fourier law, we can write the heat transfer rate equation Q for walls W1, W2 and W3 as below. Since from wall 1 temperature difference is T1 and T2, heat transfer rate is Q and thermal resistance is RT1. So we know that Q is equal to temperature difference delta T upon thermal resistance RT1. तो यहाँ पे हो जाएगा then this is T1 minus T2 upon resistance for wall 1 is RT1. So this is RT1. Let this is equation 1. Okay, now again for wall 2 same heat transfer rate is Q and again temperature difference is T2 minus T3. Then T2 minus T3 is the temperature difference upon resistance is for wall 2 is RT2. So let me call it as a equation 2. Now for wall 3 heat transfer rate equation हम लिख सकते हैं like this is temperature difference is T3 minus T4 upon RT3. Let we call it equation 3. So now we can write these three equations, rewriting these three equations in terms of temperature difference. So T1 minus T2 is Q into RT2, T2 minus T3 is Q into RT2 and T3 minus T4 is Q into RT3. So we again rewrite the equation in terms of temperature difference. So we can write here rewriting the above equation in terms of temperature difference. So this becomes T1 minus T2 is equal to Q in bracket RT1. Let this equation is 4. Again T2 minus T3 is equal to Q into RT2. Equation 5th. Then it is T3 minus T4 is equal to Q into RT3. Let me call it equation 6. So when we add all these equation, we are going to adding all these 4 equations. So you can see this is minus T2, this is plus T2. So this term is cancelled out. This is minus T3 and this is plus T3. So this T3 is the cancel out. So you can see that whenever there is a composite heat transfer in a composite wall, so intermediate temperature are cancel out. We will getting T1 minus T4. This is called overall heat transfer. Overall temperature difference between first and the last wall. So this becomes T1 minus T4 is equal to Q. Now we can add all these things. This is RT1, this is RT2, this is RT3, and if some more walls are connected resistance, so then we can add other resistance also. So we can write Q is equal to T1 minus T4. In denominator it becomes RT1 plus RT2 plus RT3. So we can write it as delta T upon sigma RT. So here delta T is known as overall temperature difference between first wall and last wall. Okay, and sigma RT is known as total thermal resistance, total thermal resistance of all walls. Here हमारे पास 3 वॉल्स हैं, तो हमने ऐड किया RT1, RT2 एंड RT3. अगर हमारे पास 2 वॉल होगी तो RT1 प्लस RT2 सिग्मा RT हो जाएगा, और अगर 4 वॉल होगी तो RT1 प्लस RT2 प्लस RT3 एंड RT4. तो जितनी भी हमारे पास थर्मल रेजिस्टेंस होंगी हम सभी को ऐड कर देंगे, देन वी विल गेट द टोटल थर्मल रेजिस्टेंस. So this formula Q delta T by sigma RT is used for composite wall also, composite cylinder also and composite sphere also. So हम आगे के लेक्चर्स में देखेंगे कि अगर हमारे वॉल्स की जगह सिलेंडर्स हैं, सपोज एक सिलेंडर के ऊपर दूसरा सिलेंडर आपने लैगिंग कर दिया, ठीक है. तो जैसे मैं अगर आपको दिखाऊं आपको कि सपोज आपका ये एक सिलेंडर है, ये सिलेंड्रिकल सरफेस आपने बना ली सिलेंडर, और उसके ऊपर आपने एक दूसरा सिलेंडर आपने इसके ऊपर वो लैग कर दिया, मतलब आपने कब तो ये 2 सिलेंडर का ही बन गया कंपोजिट सिलेंडर. तो हम आगे देखेंगे कि कंपोजिट सिलेंडर हो चाहे कंपोजिट स्फीयर हो, सो दिस बिकम्स कंपोजिट सिलेंडर, कंसिस्ट ऑफ 2 सिलेंडर. दिस इज कंपोजिट सिलेंडर. तो इन केस ऑफ कंपोजिट सिलेंडर ओनली थर्मल रेजिस्टेंस वैल्यू इज चेंज, बट द फॉर्मूला इज सेम, डेल्टा टी अपॉन सिग्मा आर टी, इनसाइड एंड द आउटसाइड. डेल्टा टी हो जाएगा, देन सिग्मा आर टी. जितने भी लेयर्स आपने सिलेंडर को आपने कंपोजिट बनाया है सबका रेजिस्टेंस हम ऐड कर देंगे, तो डेल्टा टी अपॉन सिग्मा आर टी. सिमिलरली इन केस ऑफ सपोज कोई स्फेरिकल बॉडी है, तो एक सिंगल स्फीयर है, उसका अलग रेजिस्टेंस होगा, उसके ऊपर एक और रेजिस्टेंस आपने लगा दिया, तो मतलब 3 आपने लेयर को जोड़ दिया. आपने देखा होगा जो हमारी घरों में जो स्फेरिकल वाटर टैंक्स होते हैं, तो वो भी आपके कैसे कंपोजिट वॉल की तरह से ही आपके एक्ट करते हैं. सो इन केस ऑफ सिलेंडर, कंपोजिट सिलेंडर एंड कंपोजिट स्फीयर, ओनली द वैल्यू ऑफ थर्मल रेजिस्टेंस इज चेंज, RT1, RT2, RT3, क्योंकि उनका फॉर्मूला डिफरेंट होता है. तो बट द मेन फॉर्मूला दिस Q डेल्टा टी सिग्मा RT ये सेम रहेगा, कि रेजिस्टेंस की वैल्यू चेंज होगी. ओके.